I realized that all of our lives, you and I have been buying the wrong type of paper and losing a lot of money. As an engineer, I realized that there's a mathematical principle that if you follow, you get more paper for the same price. I followed this principle, felt like a genius, and received infinite honor from my community for this discovery. But now, the time has come to actually test it. Does my method truly give you more paper for less price? Here's a story of applied math. The square cube law in geometry states that if you increase the size of an object, its volume increases faster than its surface area. It's easy to see with a cube. With an edge length of 1 meter, the initial surface area is 6 square meters and the initial volume is 1 cubic meter. If we double the edge length, the total surface area is now 24 square meters and the volume is 8 cubic meters. The volume is increased by 2 to the power of 3, while the surface area increased by 2 to the power of 2. This means that as size increases, the ratio between the surface area and the volume decreases. For papers, you pay based on weight, which corresponds to the volume, but you actually eat the surface area and you throw the inner part away. This means that according to the square cube law, it should be better to buy small papers, because then you get more surface area for a given weight, increasing your edible paper weight to price ratio. Now, if I was a string theorist, I would have just published a paper about my discovery and received eternal honor for my ingenuity. But I'm an engineer, my loves, and in this channel, we do measurements. Yeah! First, let's consider the possible results. Imagine we plot the weight of the surface area, the edible paper weight, on the y-axis, and a total weight on the x-axis. Now, let's plot a point, which is one paper, and consider the angle phi between the point, the origin, and the x-axis. The tangent of phi, which is approximately phi, represents the edible paper weight to price ratio. We want to buy papers that maximize this angle. The first possibility is a plot that leans toward the x-axis. In this case, phi is larger for large papers, so large papers have a better edible paper weight to price ratio. The second case is a plot that leans toward the y-axis, which means that phi decreases with increasing paper size. In this case, small papers have a better edible weight to price ratio. This is the plot you're expecting to have if mathematics is true. The last option is the worst. It's a straight line that means the edible paper weight is the same for all paper size. It means my hypothesis is wrong, and, unfortunately, I lost my reputation as a creative mastermind among my people. For the experiment, I measured 42 papers between 110 and 308 grams. I plotted the results. What are we gonna see? The result is unfortunately one of the straightest lines I have seen in my engineering studies. This is just said because all of my flatmates are laughing at me that I'm a weirdo that measures papers for fun and I didn't make any discovery. The true reason is that the thickness of the surface area of the paper increases with its size. But I prefer to say that this is just one more proof that theory never works. Never. But if it makes you happy, at least we have a proof now that size doesn't matter. Yeah! If you like the video and you want to help me regain my self-confidence, please like the video and subscribe for more cool science stories. See you!